Now we're going to be solving for e to the x plus 1 squared. So looking at this problem, we've done the first derivative in green, and we're doing the second derivative in red. So let's start by looking at the first derivative.
So with the first derivative, we take the 2 and we put it as our constant for some time, and then we have e2x plus 1. And then whenever we have an e2x plus 1, so we have this first number portion, then we also want to get the derivative of it. So first you can't multiply it right, you can't derive it right away, but you can derive it when it's separated from the 2, which is our constant.
And this is because of the chain rule. Remember, we're looking at the outside, kind of like an onion. We look at the whole outside, we bring this part down, and then we just set this in here, and now we have to derive the inside, which is why we have this derivation only on this part. So the next step, we derive this.
And when you derive it, of course, the 1 disappears because whenever it's a constant number, it is equal to 0, and then we have e to the 2x. And like in the previous video, you cannot derive e to the 2x, but you can derive 2x, which is where the 2 comes from.
Technically, you can derive e to the 2x. When you derive e to the 2x, it's just itself, though. So it's just e to the 2x. When you derive e to the 2x, you just derive that. And the only reason why we have this 2 out here is because of the chain rule, and we have to derive this part. Now, this step is just really rewriting it. We're just multiplying this 2 by this 2, and it gives us this 4. And this step is also just rewriting it. And in this step, we are factoring out this e to the 2x. So we're not really factoring it, we're just moving it to this side. So we have 4 e to the 2x, and we have e to the 2x plus 1. So this is our very first derivative. Now we're going to look in red, and we're going to start solving for the second derivative.
So for the second derivative, we're actually going to take e to the 2x and multiply it into the equation, so we get e to the 4x, because when you multiply the exponents, you're basically adding them. E to the 4x plus e to the 2x, because e to the 2x times 1 is 1. Is e to the 2x. And then you keep the 4 out as the constant. Now, once you have this, you start to derive it. So 4 stays as a constant, and then e to the 4x, and of course the exponent is going to be derived, so you get 4, plus e to the 2x, exponent is derived, and you get 2. Then you multiply them, so you get 4 to the e 4x, plus 2 to the e 2x. Then you multiply in the 16e 4x plus 8e 2x. Now, you want to simplify it, easiest way that you can. Well, of course, 16 can be divided by 8, and 8 is already in the equation, so we're going to keep e.
Well, 8's the smaller of the two, so you want to look at the smallest one to factor out.
And then 8e2x times 2e2x plus 1, because 2 times 8 is 16, and there you go.
Right, so in here, it would have been easier if we just kept this 4 factored out. My friend's still learning the derivatives, but that's okay. So if we would have kept the 4 factored out, we could have also factored out the 2, and then we just have to factor out the e to the 2x. So that would go out there, and then we would have our equation simplified just like this.